Today I'll be discussing the rules and responsibilities of the various parties involved with special inspection projects and our interpretation and experience with the building code special inspections. We've seen a wide variation across the state with codes enforcement involvement. A lot of the larger cities with full-time codes departments are very involved with projects versus some of the smaller cities. So to start with a little background, the building code in New York State was updated for 2020, and it's based on the 2018 International Building Code. Now there is a last fall, the International Building Code came out with a 2021 version. However, New York State's code is based on the 2018. And states surrounding New York, they're typically using the 2015 or 2018 International Building Code. But the building code provides the minimum requirements for building systems, and it's intended to establish provisions that adequately protect public health, safety, and welfare of the occupants, and applies to all types of buildings and structures unless they are exempt, which I'll go through some of those exemptions, including 1- and 2-family dwellings and structures that are not within the scope of the residential code. So some of the exceptions to the building code, as I mentioned, are structures that fall within the residential code, and those are typically residential dwellings less than 3 stories in height. Agricultural buildings, consisting of barns, sheds, chicken houses, and other structures used solely for agricultural purposes. Temporary construction trailers, the trailers you would see on a typical construction site for the contractors and project managers. Radio, television, communication, wind generation towers, and solar arrays. Although these structures are exempt, we do a lot of work on these structures. So the designer of these structures typically specifies certain tests and inspections to be performed for those structures. And then finally, children's camp sleeping quarters. The documents that are required to be submitted with the building permit application include construction documents, typically the project plans and specs, statement of special inspections, the geotech report, as well as any other data submitted with the permit application. And in any event, the construction documents, the plans and specs shall be prepared by the registered design professional. So special inspections aren't anything new to the construction industry. Inspections were part of the first Uniform Building Code back in 1927. And in the early 60s, the term special inspection was introduced into the Uniform Code. But special inspection really came to the forefront in the early 80s after a walkway collapsed at a Hyatt in Kansas City, where 114 people lost their lives. And after that collapse, a House subcommittee, which was chaired by Al Gore, investigated that, and out of that, they recommended that comprehensive inspections should be performed for critical structural items during construction. So a special inspection is the monitoring materials and workmanship of the contractor to ensure that the approved construction documents and codes are being followed. And Chapter 17 of the code, that's the pertinent chapter that has the procedures and criteria for the inspections and testing. Chapter 17 also outlines the responsibilities of the owner, contractor, the design professionals, as well as the special inspectors. And the special inspection process, that's in addition to any structural observations, which will be required by the design professional. And at the end of the project, a final report is required for certificate of occupancy, stating that the work was performed in accordance with the plans and specs. And that brings us to question 1.
Go ahead, Brian.
Okay, question 1. The 2020 building code is based on what IBC version? The answer is C, 2018. As I mentioned, IBC does have a 2021 version, but that probably in about 3 years, New York will probably start adopting that one. So under approvals for Chapter 17, the agency should be approved by the building code official, and special inspections are conducted by an agency that is regularly engaged in conducting tests and providing inspection services. So prior to construction, the approved agency needs to submit information to the building official that they are independent from the contractor, and they shall disclose any possible conflicts of interest to the codes enforcement official, as well as the design professional. They should also demonstrate they have adequate and calibrated equipment to perform the specified tests, and information or documentation that they have properly trained personnel to perform the inspections. Under reporting, the approved agency is going to keep records of the inspections and tests, which will indicate if the work was or was not performed in accordance with the approved construction documents. And any discrepancies need to be brought to the contractor's attention so they can correct it. And this is probably one of the most important aspects of the reporting, to make sure that discrepancies get fixed before any future work covers up the discrepancy, so it can't be fixed or inspected later on. So it's always a good idea to have a pre-construction meeting to outline the process of reporting discrepancies, to make sure the inspectors have the right contact on the site for the contractor. It's not the inspector's responsibility to accept or reject any work that's not in conformance. So an example of this is a concrete. If concrete's delivered to the site and it doesn't meet the specification for slump or error, the inspector needs to tell the contractor, and then the contractor needs to decide if they're going to reject the truck, try to fix that, or incorporate that deficiency into the work, and then hopefully try to get that discrepancy cleared up later on with the RDP. If discrepancies aren't corrected, then they need to be brought to the attention of the building official, as well as the registered design professional. And the reports documenting the inspections and tests need to be submitted regularly to the owner or the authorized owner's agent, as well as the building official. A statement of special inspections prepared by the RDP or a qualified person approved by the building official should be submitted with the permit application. And that's going to list the materials, any of the systems components or work, which is going to require testing and inspection. It's also going to list the type and extent of each test and inspection. If the structure is designed to resist seismic and wind forces, any of those additional inspections, as well as the frequency of inspections. And the building code breaks down the frequencies into two categories. The first is continuous, where special inspection by the special inspector, who is present continuously when and where the work is being performed. So an example of this would be if the contractor's backfilling a foundation wall that's 12 feet high, and specifications require the fill to be placed in 12-inch lifts and compacted to 95% all the way up. The inspector's pretty much got to be there full time to verify that work is in compliance. Periodic inspection, that's special inspection by the inspector who is intermittently present where the work is being performed. And in some cases, less than 100% may be acceptable. So an example of this would be reinforcing steel in a long foundation wall. It may take the contractor a week to erect that reinforcing steel. However, the inspector can get there sometime just prior to concrete placement to verify whether or not it's in compliance. So the inspector doesn't need to be there full time when the contractor's inspecting for that, or when the contractor's erecting the reinforcing steel full time. So this is a case document, statement of special inspections. A lot of RDPs use, and along with that, there's typically a schedule. So the RDP can just check off what items are going to require testing and inspection on a project, and it's going to list the inspection firm with their contact information. And one of the things I want to note down on the bottom, it does state the inspectors and testing agencies shall be engaged by the owner. That way there's not a conflict of interest. Here's an example of a schedule of special inspections. So for this specific project, this is the soils and foundation portion. So the RDP has outlined what tests and inspections are going to be required on the project for the soils and foundations. Now, this particular project had rock anchor foundations, which aren't specifically discussed in the building code. However, the RDP thought that that was an important inspection item, so they listed that in the schedule of special inspections. So you can see here they've also put the agent that's going to be doing the inspections. So for this project, number 2 was a geotechnical engineer. And they've also specified that the geotechnical engineer also be a professional engineer. And then number 3 is the testing agency. And on some projects, the inspector and testing agency are the same firm, which in most cases should save the contractor some or the owner money. They've also identified what inspection items are going to be continuous and which are going to be periodic. And they've identified the percentage level for periodic inspections. And then the other thing they do, which is kind of nice, is they put in what the reference standard is for the inspection items. And that brings us to question 2.
Please continue, Brian.
Okay, question 2. The statement of special inspections is prepared by who? Answer is A, the registered design professional. So moving on to some of the special inspection and test exemptions or exceptions. One of the exceptions is any work that is minor in nature or as warranted and approved by the building official. Unfortunately, there is no definition for minor in nature, so that's really up to the building official. One of the other ones is for group U occupancies. They're accessory to a residential occupancy. For lightweight structures. And one of the new things to the code, or at least language, is the contractor is permitted to employ the approved agency, where the contractor is also the owner of the project. So to get into some of the roles of the different parties involved with the special inspection process, the building code official, they're the ones that have the legal authority over the project, and they're the ones that are going to issue a stop work order for any non-conformance items. They're going to review the submitted plan specs for compliance with the building code. They're also going to approve the special inspection program as well as the agency and the inspectors. They're going to monitor the special inspection activities during construction, review special inspection reports, and then perform a final inspection, which is typically going to happen after the final special inspection report is issued. They can also require inspections for other work that they feel may be necessary for the project. The role of the special inspector. They're going to verify that the work and the materials used in construction conform with the construction documents, and notify the contractor of any non-conformance issues, so those can be fixed or resolved with the RDP. Unfortunately, the special inspector, they can't issue stop work orders. Only that can come from the building code official. They're also going to document and report any non-conformance items that are outstanding to the owner, the RDP, as well as the building official. Then at the end of the project, they're going to submit a final report, which will outline the inspections as well as discrepancies and how those discrepancies were resolved. And finally, it's not the special inspector is not responsible for any of the contractor's means and methods or any job site safety for the project. Qualifications of the inspectors. Prior to construction, the approved agency shall submit written documentation demonstrating the competence and experience of the inspectors who will be performing the tests and inspections. And down on the bottom, the RDP can act as the approved agency, and their personnel can act as a special inspector if they're qualified and experienced in the type of work that they are inspecting. The role of the owner. The owner is going to employ the approved agency as well as the special inspectors, so there's not a conflict of interest. And they're also going to maintain the statement and seek approval from the building official if there's any changes required as the project progresses. The RDP. The RDP is going to prepare the special inspection program and what items are going to require special inspection, As a designer of the project, they are best suited to prepare the program, since they're the most familiar with the aspects of the project. They're going to respond to any field discrepancies if they're contracted to do so. It's not uncommon to have a discrepancy where the contractor can't construct a portion of the work in accordance with the approved documents. So in a case like that, it's marked as a discrepancy, and it's typically addressed by the between the RDP and the contractor to come up with a solution. They also review the shop drawings and will submit revisions to the approved plans as needed. The role of the contractor is going to notify the special inspector that work is ready for inspection. And it's important they provide sufficient notice so the inspection agency can coordinate their staff and equipment. The last thing we want to have happen is have the inspector out there at the time of concrete placement, because if there are any discrepancies with the formwork of the rebar, then that's going to put the concrete placement off. They should provide access to the approved construction documents in cases where any changes have been made to the specifications or drawings. We have had instances where inspectors have identified discrepancies, brought that to the contractor, and then we found out later on there was a change to the drawing that didn't get down to the inspection agency. And then lastly, they need to provide safe access to the work that is being tested and inspected. So they may have to provide lifts or shoring for subsurface work to be inspected. So some of the special inspection items in the code, we're going to go through these in more detail, but soils, which applies to shallow foundations and fill materials. Deep foundations, which can be driven, cast in place, helical piles. Concrete construction, masonry construction, structural steel, sprayed fire resistant materials, and then mastic and intumescent fire coatings. There are other special inspection items identified in the code, such as wood and EFIS. However, this list is the typical items that we see on projects in our area. So for soils, the special inspector is going to determine general compliance with the approved soils report and documents prepared by the RDP during site preparation. So prior to construction, geotechnical report should be prepared that's specific to the soil and groundwater conditions at the project site. And from that, the structural and civil engineers will use that information to prepare their specs and drawings. And in a lot of cases, they will just specify on the drawings to prepare the site in accordance with the geotech report. So the second item, the inspector is going to verify the shallow foundation subgrade is suitable to achieve the design bearing capacity, which is basically going to involve comparing the site observations at the time of the excavation work to the conditions that were identified in the geotechnical report to make sure they're consistent. The inspector is going to verify excavations extend to the proper depth and material, which is typically going to be dictated by the frost depth. The frost depth in northern New York is typically 5 feet below grade, whereas southern part of New York, typically the foundations are placed 4 foot below grade for frost protection. There may be other situations too where there may be fill at the site that the geotechnical engineer recommends placing foundations below the fill. So the foundation should extend below fill or below the frost depth, whichever is deeper. They're going to verify the bearing subgrades have been properly prepared. This is for slabs and for footings prior to fill placement. And typically that's verified through proof rolling with a roller or a dump truck where the inspector can monitor and identify any soft areas that need to be remediated before fill placement starts below structures. Then they're going to verify the use of specified fill materials, making sure that the material that is being brought into the site is approved. Lift thicknesses, if the specifications call for 8-inch lifts, making sure the contractor place 8-inch lifts. And then finally, compaction of the fill. If specifications require 95% of a modified Proctor, that's what the inspector is going to verify in the field. So I'm just going to run through some examples here, some example photos. So the photo on the left, this is a foundation excavation, and I think this is in central New York. So the frost depth is 4.5 feet. So the contractor excavated to the proper depth, 4.5 feet. However, you can see in the photo there's standing water and mud. And per pretty much all geotechnical reports and building codes, mud and standing water has zero bearing capacity. So this would be a discrepancy. So the inspector would review the project plans, specs, the geotech report, and typically there will be information in those documents on how to remediate this situation. If there isn't information in there, then typically the inspector will go back to the registered design professional to get guidance on how to resolve this discrepancy. So for a typical situation like this, it's usually specified that the contractor over excavate maybe 6 inches or to stable material, and bring in compacted fill, as well as employ some dewatering measures to get rid of the standing water. The other thing that does is it's very hard to place rebar in mud. The rebar gets dragged through mud and then contaminates the rebar, and also for tear support to keep the rebar up in the right spot. It's difficult to hold the rebar position when you have standing water and mud. The photo on the right, there was a project where the geotechnical report identified some organic materials at the foundation subgrade elevation. So the recommendation was to remove all those organics down to a stable layer and then bring the foundation subgrade back up using lifts of structural fill. So you can see in the photo here, you can see the lifts of structural fill. You can see the compactor there. So this material was placed and compacted in accordance with the project specifications. When I give this presentation in person, I usually have samples that I pass around, but with the webinar format, I had to take photos. Sometimes specifications may call for geotextile to be used, and there's various types of geotextiles depending on the situation. But I just want to show the different types here. So this type is it's a woven polypropylene. So you can see the individual polypropylene strands that are weaved together. And these are very strong. Geotextiles are typically used for stabilization below roadways, below slabs. So they provide good stability. The one problem, some of them do not allow water to pass through them very easily, so they can collect water on top of them. But they're typically used for stabilization over softer subgrade soils. Versus the non-woven geotextiles, These are needle punched polyester or polypropylene fibers. And these fabrics aren't as strong as the woven fabrics, but they do allow water to pass through them. So they're typically used for separation and for drainage applications, such as used for a foundation drain around a footing. There's sometimes confusion between the New York State DOT number 2 stone and the DOT type 2 subbase materials. So I've got a couple of photos here. The photo on the left, this is a DOT number 2 stone, and you can see it's an open graded stone. It's very, very good for drainage. It's typically used for drainage purposes. It's also used as a concrete aggregate for concrete mixtures. But one of the things with this is in the field, because it is such a coarse material, it's not possible to do the typical field compaction testing on this material to verify it's compact. But because it is open graded, typically the specification is to compact it 4 to 6 times with a certain size compactor. The photo on the right, this is a type 2 subbase, and this is a material you typically see below a slab or below a pavement. And it's a well-graded processed material. And because of the fine content in it, it can be tested in the field for compaction in accordance with the typical project specifications. Natural versus processed aggregates. The photo on the left, this is a typical bank run. You can see the aggregate particles are rounded over versus a processed aggregate, where this is from a crushing lead rock operation. You can see the particles are angular. So it's important for the inspectors in the field to know what the different materials are. That way, when they're comparing what they see in the field to approved submittals, they can verify that the right materials are being utilized in construction. There is one exception to a soil special inspection, and that is where fill placement, there's no fill greater than 12 inches across the site. It doesn't need special inspection. However, it does require compaction to 90% of a modified Proctor in accordance with ASTM D1557. And that brings us to question 3.
Please continue, Brian.
Okay, question 3. The special inspector can issue a stop work order on a project. True or false? Answer is B, false. The building code officials, the one that issues stop work orders. So moving on to driven deep foundations. These are typically going to be steel H piles, steel pipe piles, or timber piles that are driven with a large impact hammer to support structures over poor soil conditions. So in the field, the inspector is going to verify the pile material, the pile size and pile length. They're going to observe any driving activities and maintain a record for each installed pile, which will include the penetration resistance, which is how many blows of that hammer it takes to drive the the pile over an inch or a foot increment. They're going to monitor or record the top and bottom elevations of the pile, the hammer type and size. Typical hammers in our area consist of diesel hammers, air hammers, or a hydraulic hammer. They're also going to monitor pile damage. Sometimes piles can be damaged if they're driven to bedrock, or if they're driven through cobbles and boulders. And the other thing with cobbles and boulders, sometimes it's hard to maintain the pile location as well as the pile plumbness. So that issue, it's a pretty common one. So it's important to notify the RDP if there is a discrepancy. That way they may want to install an additional pile, or they'll look at it and determine that the pile is okay as is. They're going to determine the capacity of piles based on either static or dynamic load tests. Typically for driven piles, dynamic load tests are specified because they're quicker and cheaper, as well as any additional tests. So for steel piles, if those piles require a splice, there's going to be some weld inspection involved with that. With concrete, with driven pipe piles, oftentimes those pipe piles are filled with concrete. So there'll be some additional inspection and testing involved with the concrete placement in those piles. So the photo on the left, this is an H pile that's being lifted up into the leads, and up top here is a big, this project had a big diesel hammer. So once the pile is put at its location, then the hammer is going to drive that pile into the ground to a specified depth and a specified capacity. So the capacity is determined during field testing. So this is the photo on the right. That's a photo of a dynamic test that's being conducted on pile. And the sensors that are on the side, they measure the capacity, or they're used to measure the capacity as well as the stresses in the pile to make sure the pile is not being damaged as it's being driven. So what the inspector needs to do, you can see that this pile has marks on it. So during the testing, the inspector is going to monitor how many blows of that hammer it takes to advance that pile each 1 inch into the ground. And from that information, as well as the testing that's being conducted, they can determine how many blows per inch is required to achieve a capacity for that pile. And here's a photo of a pile that's been installed. You can see the markings on it. So some projects could have up to 1,000 driven piles on it. However, typically we're only testing a handful of piles, either dynamically or statically. So once that correlation is developed, the blows per inch for capacity, then the inspector is going to verify all the other piles that are installed are driven to that same criteria using the same driving system that was used for the test piles. And then the photo on the right, that's just a typically of what you would see of pile damage if a pile was driven to bedrock, or if you had cobbles or boulders. Cast in place deep foundations. These typically consist of drilled concrete piers, micro piles, or auger cast piles. And with these, the inspector is going to monitor the drilling activities and maintain a record for each one. Verify the location, the plumbness, verify the diameter of the piles, the length. Typically, especially with the drilled piers and the micro piles, they're going to be embedded into bedrock. So the inspector is going to verify that the design embedment into the bedrock is achieved through visual observation on site, as well as the information from boring logs contained in the geotechnical report. And then they're going to also monitor the concrete and grout volumes that go into those deep foundation elements. And then there is some additional testing as far as concrete or grout, whichever is used to cast the units. So with the cast in place elements, there's typically an auger or some sort of casing and drill bit that will create a void down to a certain depth. And then that void is going to be filled with concrete or grout material. And then sometimes for the larger drilled piers, there may be some rebar cages that are placed that will require some reinforcing steel inspection. Helical piles, these are small diameter, either square or round shaft piles, which have plates that are screwed into the soil to support structures through softer, poor soil conditions. So the inspector is going to monitor the installation activities, verify the installation equipment that's on site is specified and approved, monitor the pile dimensions, the top and bottom elevations, as well as the final installation torque. And with the helical piles, bearing capacity of the piles is related to the installation torque. A couple ways the inspector can do that. There are torque gauges with the equipment that the inspector can visually look at, or sometimes there's shear bolts that shear off when a certain torque is met. So once those bolts shear off, then the inspector knows that they have the required torque and the required capacity. And then the typical additional testing would be if there's any grout that's being installed with these helical piles. So the photo on the left, that's a helical pile installation. So you can see the helical pile. It's got a small diameter shaft, and then there's plates that are screwed into the ground with a torque head. Right here's the torque head. So the advantages of these are they go in pretty quick. You can use small equipment. And they can be installed in areas where there's low headroom. Typically, these sections are going to be 3 to 7 feet in length. So it's easy just to keep adding sections on as they're being installed into the ground. And then here's some installed helical piles with plates on the top, which is going to be, these are going to be used to support a strip footing for a project. And that brings us to question 4.
Please continue, Brian.
Okay, question 4. The special inspector is hired by who to perform special inspections on a project? The answer is C, the owner. So I've got about 10 minutes. I'm gonna have to get through some of these slides relatively quick. So I'll move on to concrete construction. Prior to pouring concrete, the inspector is going to verify reinforcing steel placement and welding, making sure the reinforcing steel is the right size, spacing, clearance. The installation of any anchor bolts, making sure they're the right grade, right size. The use of the required mix design. It's not uncommon on larger projects to have maybe 5, 6, 7 mix designs. So it's important the inspector be familiar with each one and what areas each mix can be utilized in. sampling and testing of the concrete, air, slump, temperature, fabrication of test cylinders during the concrete placement, curing temperatures and techniques for both cold and hot weather concreting, any pre-stressed concrete, precast concrete structures when those are erected, in situ strength before the contractor can remove forms, shoring. Sometimes there's a minimum compressive strength that the concrete needs to meet before that can happen. And then finally, the formwork, shape, location, and dimension. So one of the things the inspectors need to look at on site is the rebar, and all rebar has markings. So the first marking on the rebar is going to be the plant that the rebar was fabricated in. So again, that's good to know so that when the inspector is looking at a material submittal, they can match up that that submittal matches what rebar was being brought on site. The second spot down is going to be the bar size, and there's a 13 here, which stands for 13 millimeter. This is a metric bar, so it's actually 1/2 inch in dimension, or it's a number 4 bar in English units. Third spot down is the steel type. And for this bar here, S designates billet steel, which is typically what you would see on a project site. If there's welding of steel going on, there might be a weldable steel, which would have a W for that spot. And then the fourth spot down is going to be the bar grade. So since this is a metric bar, the number 4 represents 420 megapascal, which is 60 KSI English. This sometimes trips inspectors up because they think that 4 there is grade 420, but if this was an English number 4 bar, that 4 would not be there. There would be a separate smaller rib here, which would designate grade 60 steel. This kind of shows how busy things can get in the field. On paper, this looks good with nice straight lines, but in the field, there's a lot going on. So again, this kind of shows it's important that the inspector takes a look at this with as much time in advance to concrete placement, because if the inspector did find an issue down at the bottom part of the steel, it'd be very hard to fix that within a short time. And there are tolerances, so the inspector will have to evaluate if all this reinforcing steel is within the appropriate tolerances. This is a project that was done during the winter time, and part of the specification was the contractor had to submit a cold weather plan, which was to cover the area that was being poured. This is a deck, so underneath they actually heated the deck underneath, so part of the plan was they had to maintain a certain temperature. The rebar had to be a certain temperature before they could pour. So those are all things that the inspector had to look for. The inspector looked at this the day before, and everything was in conformance, but the day of the pour, you can see the contractor had to move the pipe around from the concrete placement and cause some of the rebar to be out of tolerance. So luckily the inspector was there that day and they were able to fix that before that was poured. This is an example of the test cylinders that the inspectors and testing agencies will use to fabricate concrete test specimens. So there's 2 types that can be specified. 6x12s on the left or 4x8s. With the 4x8s, 3 of these need to be tested at 28 days to verify concrete strength, whereas with the 6x12s, only 2 are required to verify the concrete strength. And there are some exceptions to concrete special inspection. They're typically for lightweight structures, patios, driveways, sidewalks. There are exceptions. However, specifications usually require the concrete be tested for those areas. And most agencies will have a checklist that their inspectors fill out. So this is just a typical one that they can go through and check off the item that they looked at and whether or not it was in conformance. And again, most agencies will have a discrepancy list. That way there's a running tally of what the discrepancies are and how they're resolved. Masonry construction, inspections are going to be performed in accordance with the QA requirements of TMS 402, TMS 602. These used to be published by ACI 530. However, since 2016, they've been published by the Masonry Society. And they basically break down the inspections into 3 levels, level 1, 2, and 3, with level 1 being the least stringent. And the only thing that's required for level 1 is just verifying compliance of submittals prior to construction. Whereas level 2 and 3, they require field inspections and tests, with level 3 being the most stringent, with more inspection items, and more items are continuous inspection instead of periodic. But these are the items the inspector would typically verify in the field. So verifying the units are the right size, that the rebar is in the right cell. When the contractor grouts, making sure grout is placed in the right cell as well. And then for any cold weather construction, is making sure that those procedures follow the contractor's cold weather plan. There are a couple exceptions to masonry. Again, they're typically for non-load bearing structures. Structural steel, there's been a lot of changes in this area over the last few years. And the inspections are performed in accordance with the QA inspection requirements of AISC 360, Chapter N. And that consists of any welding of structural steel, steel framing, as well as high strength bolts, nuts, and washers. And the frequency is no longer in the building code. However, the TMS documents, they do have frequencies, but they define them as observe, which are random inspections, and perform, where each joint or steel member needs to be inspected. And there are a couple exceptions, which I have listed here. So you can see here, for the inspector to be able to verify that connection, we would need a lift to get up there. We would need stable ground for the lift as well. For bolts, basically the inspector is going to verify the right bolts are being installed. There's a full nut. With the TC bolts, these bolts are designed so that this spline right here snaps off when this bolt is torqued to a specified torque with a torque wrench. So this is an item where the contractor can pretty much go around and install all these, and then the inspector can go in sometime after that and just verify that all these splines have been snapped off. And that's the same thing with these tension indicator washers. These washers have paint, and when the bolt is taken up to a certain torque, then the paint squeezes out. So the inspector can go around and make sure that paint is observed around all those washers. And then similar to rebar, bolts are going to have markings on them which designate the steel grade, as well as where the bolt was fabricated. And that brings us to question 5.
All right, in the interest of time, I have 2 questions, and the first one's a short one. Can design professionals perform special inspections?
Yes, the design professionals can perform special inspections, just as long as they're qualified and have experience with what they'll be inspecting.
Please continue.
Okay, question 5, which is not an inspection item for concrete construction? And the answer there is D, classification of fill materials. So last couple slides here, sprayed fire resistant materials. Basically, the inspector is going to monitor temperatures before and after application. These materials are cementitious, so they need to have proper curing temperatures. And the other big one is making sure the structural member does not have any moisture or surface rust on it, which would prevent the fireproofing from adhering to it. And then the mastic and intumescent. The inspection items are listed in the wall and ceiling industry document, which is listed here. But basically, you know, similar to the cementitious materials, temperature and humidity, as well as surface condition, and then thickness of the material are all inspected with those coatings. And if there is fireproofing, there are no exceptions to the building code.